math with Mr. B. It's fun for you, and it's fun for me. You did your homework, now you got a test. We're gonna review so you can be your best.
All right, question number 5. The question says, a rectangular park is 150 yards on one side and 125 on the other. I went ahead and drew a picture. You got 150 yards on this side, 125 over here. And it says, if Debbie walks around the park 2 times, how far does she walk? We're going to sketch the figure and show your work. So I already sketched the figure for you. Here's the rectangle. There you go. So we're going to go around it 2 times. So each time we go around the park, that's going to be the perimeter of the park. So the perimeter, we know, is the distance all the way around. So we have a side with 150. We have a side with 125. But then we have another side over here with 125 and another side with 150. So I can actually just go ahead and multiply both of these by 2. So 150 plus 125 gives me 275. 275 times 2 is going to give me 550. And we know that's the distance now 1 time around the park. But the question says if she walks around the park 2 times. So if we're going around 2 times, we're going to have to take this number, 550. And we're going to multiply that by 2. And that should give me 1,110. And it's yards. Don't forget your units. And there we go. Now for letter B. It says if she wanted to walk 1 million yards, how many times would she have to walk around the park? So now we're starting from the distance that she wants to cover. We know that 1 time around the park is 550 yards. This is 1 time. So what we're going to do is we're actually going to take the total distance that she wants, which is 1 million. And we're going to divide it by 550, and that's going to give me the number of times she's going to need to go around. So I divide this by 550. And I'm going to go ahead and break out the calculator for this one. So we start with 1 million, and we're going to divide it by 550. And we get, as you can see, 1,818.18. And it goes on for a little bit. But that means the question was, how many times would she have to walk around the park? So to go above this number, she's going to have to walk 1 extra time. So our answer is going to be 1,819 times. All right, here we are with question 6. Tom keeps all of his favorite marbles in a special leather bag. Right now he has 5 red marbles, 4 blue marbles, and 3 yellow marbles. I drew you a little picture in case you couldn't visualize it. So, for letter A, it says if he randomly chooses 1 marble to give to a friend, what is the probability that it is blue? We know that to find the probability, we need the number of outcomes that we want, successful outcomes, over the total number of outcomes. So the first thing we're going to say is, how many total marbles are there in the bag? We have 5 reds, we have 4 blue, and we have 3 yellow. Add these all up, that means it's 12 in total. Now the question was, what's the probability that he is going to pick a blue marble? So we know there are 4 blue marbles. So we're going to put 4 over our total number of marbles. And we can actually reduce that now to 1/3. So the probability is 1/3 that he will pick a blue marble from this bag. Now the follow-up to that is this a theoretical or experimental probability? Now, we didn't actually pull anything out of the bag. We're not going off an actual experiment that we did. We're just doing it based on how the bag is set up. So that's going to be a theoretical probability because it's what should happen in theory, not what actually happened. All right, letter B. Tom does not really want to give away blue marbles and would like to change the probability that he chooses a blue marble to Okay, letter B. So, Tom does not really want to give away blue marbles. And we know that originally the probability of getting blue was 1/3. But now what he wants to do is he wants to change the probability so that when he chooses a blue marble, the probability is 1/10. How many marbles that are not blue could he add to the bag so that the probability of choosing a blue marble becomes 1/10? So I know that my probability to start with was 1/3. More importantly, I know that I have 4 blue marbles, and I can't change that number. But what I can change is the total. So since I know that my probability is going to be 4 over the total, and I want that to equal 1/10, I can look here and I can say 4 over what is equal to 1/10. So there's a couple different ways you could look at this. I like to look at it this way. What would I multiply 1 by to get back to 4? And that's 4. And I check the bottom. If I took 10 and I multiplied by 4, what would be my total? It would need to be 40. So 4 over 40. And then I actually check my answer the other way just to make sure. So I divide both top and bottom by 4. And sure enough, it's equal to 10. There's the school bell. So I know that I need to have 40 in total. And I started with 12 in total. So I need to take 40, I subtract 12, and that'll tell me how many I need to add. So 40 minus 12 gives me 28. So 28 marbles is how many I need to add. All right, the last problem, number 7. We're going to find the perimeter and area of each figure here. So for letter A, we have this figure. We don't have any dimensions written in there, but each one of these squares we're going to assume is 1 unit. So to find the perimeter, I'm actually just going to count around the outside. So I like to mark mine just so I know where I started from. So we're going to count just the outside squares. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, and 18. So our perimeter here is going to be 18 units. And for area, it's a similar concept. We're just going to count the number of actual squares here. So I have 1, 2, 3, 4, 5, 6, 7, 8, and 9. So I have 9 units, but in this case, it's squared because it's area. And there's the bell again. Okay, 7B. So again, we're still looking for the perimeter and the area of this figure. And so again, just like we did last time, we know the perimeter is going to be outside the shape. So I know I have a side that's 7. I know there's a side that's 5. And then again, there's a side that's 7 and a side that's 5. So 7 plus 7 gives me 14. 5 plus 5 is 10. So I know that's going to be 24 feet. And for area, this is a parallelogram. So to find the area of a parallelogram, we are just going to do base times height. But the height is this distance here, coming up 90 degrees at a perpendicular angle from the base to the other side. So we're going to go ahead and do 7 times 4. And 7 times 4, as we hopefully know, is 28, and that is feet squared. Awesome. Okay, on to C. So for letter C, we have a rectangle. And that rectangle has a side of 8 centimeters and a side of 15 centimeters. To find the perimeter, add up around the outside. We will have a side that is 15, a side that is 8, a side that is 15, and another side that is 8. So 15 plus 15 gives me 30. 8 plus 8 gives me 16 for a grand total of 46. And I need my units, so they are centimeters. For the area, we know the area of a rectangle is length times width. So in this case, it's 15 times 8. 8 times 10 would give me 80. And 8 times 5 gives me 40, so 40 plus 80 is going to give me 120 centimeters squared. Okay, moving on to D. We're almost there. Letter D is a trapezoid. Ooh, that's not what it looks like. Let's try that again. It looks something like this. And we know that this is 5 inches, this is 8 inches, We have a height of 4 inches, 6 inches on that side, and 15.5 inches. So a nice thing with perimeter is we just keep doing the same thing. We're just going to add up the outside. So I'm going to go ahead and do 5 plus 8 plus 6 plus 15.5. 5 plus 8 is 13. Plus 6 gives me 19. 19 plus 15 is going to give me 34, and then I have that 0.5 left over. Keep your units. They are inches. Great. And then for area, this is a trapezoid. So the formula for the area of a trapezoid is the average of the two bases. So 8 plus 15.5. And it's an average. We're dividing it by 2. And then we're going to go ahead and multiply it by the height, which again is this line going 90 degrees straight up from base to base. So that's going to be times 4. I can see right away that 2 goes into 4 2 times, so I can simplify that. 8 plus 15.5 is going to give me 23.5. And I'm still going to multiply that by 2. 23.5 times 2 is going to give me 47 square inches. Fantastic. And now the last one for this review, I will go ahead and get a nice new sheet of paper. Letter E now for 7 still. We have a triangle. And this side is 8.5 millimeters. This is 6 millimeters. We have a height of 4 millimeters. And this bottom side is 12 millimeters. Okay, so perimeter, add up the outside. 6 plus 8.5 plus 12. I know that 6 plus 12 is 18, plus another 8 gives me 26, and I still have that 0.5. And for the area, we know the area of a triangle is 1/2 the base times the height. In this case, 12 is the base, and the height is 4. So again, I could simplify it here. 2 goes into 4 2 times. 2 times 12 gives me 24 millimeters squared. And we've reviewed